All right, once again, our little trick that I'm going to have you guys keep in the back of your head as we go through this review / go through your final is whenever you see a quadrant number, make sure you draw the triangle. So find the value of tangent cosine inverse of -3/8 in quadrant 3. So when we get a question like this, we want to work from the inside out. So do this cosine inverse thing first. But don't think too hard about it. This first part just tells us how to draw the triangle, okay? So it gives us the information to make our triangle. Nothing about the calculator, nothing needed. So I'll just show you here. This was in 4.7. If you're looking for a reference point, you're like, oh my God, when did we do this? This was a 4.7 type question. All right, so quadrant 2, there's our shape. So cosine is -3/8, so adjacent is -3, hypotenuse is 8. So we're going to find that missing side. So we're going to say -3 squared plus b squared is equal to 8 squared. 9 plus b squared is equal to 64. B squared is equal to 55. And you can't take the square root of that nicely. So that's just going to be the square root of 55. You get 5 and 11. Nothing you can do there. So 5 under the square root there. Okay, so this part tells us how to draw the triangle, and then actually once we've drawn the triangle, this is what we find. So I want the tangent of theta, and that's going to be opposite over adjacent, so root 55 over -3. There you go, that's how you do it. All right, now 14, 15, and 17 are all solve it questions. I think these are probably a little bit more challenging than the ones on your final. These are all 6-1, 6-2, and 16 is going to be just using a sum and difference formula to prove it. So I'm not going to do 16 because we've talked about sum and difference formulas. We've done a similar problem in your notes. So 16 I'm going to hold off on, but I know that a lot of us struggled with this, that 6.1, 6.2, 6.3 section. So we're going to do a lot of these. Or I'm going to kind of get you guys started. So solve -2 cosine theta is equal to sine 2 of theta minus cosine theta. Okay, so first things first, let's get everything over to one side. So let's add this 2 cosine theta over. All right, so now I have 0 is equal to sine 2 theta, and then I have cosine, negative cosine plus 2 cosine. That's just going to give me 1 cosine theta. All right, so everything's over to one side. Now the other part of this problem that we have here is that we have this double angle with a single angle, so no good. So we want to make sure, we want to try to get only single angles, okay? All right, so we have our identity for sine of 2 theta, and that's going to be 2 sine theta cosine theta plus cosine theta. So how did I know to change sine 2 theta and not change cosine of theta? It's because I don't have anything to change cosine of theta to. There's no other cute identity to use, nothing to do. So the only option I have to work with is the sine of 2 theta. So now that we've rewritten it in terms of single angles, right? Sine theta, cosine theta, cosine theta. What I'm going to do is I'm going to see what each of these terms have in common, and they have a cosine in common. Now remember, we do not divide by the cosine we factored out. We cannot divide by a function. So I'm going to factor out this cosine and get cosine of theta times 2 sine of theta plus 1. So now I have two trig problems. I have cosine of theta is equal to 0, and I have 2 sine of theta plus 1 is equal to 0. Now I want my answers between 0 and 360. Cosine of theta is equal to 0. If I think about the graph, which is the way I like to think about it, cosine is 0 at 90 degrees and at 270 degrees. All right, so those are two answers there. And then sine theta, so that I get 2 sine theta plus 1 is equal to 0. And I would get sine of theta is equal to -1/2. All right, so this is going to occur at when your reference angles are 30 degrees. And that's going to occur in the third and fourth quadrant because sine is negative. So reference angle is 30 degrees. In the third quadrant, 180 plus 30, that's going to be 210. And then 330 in the fourth quadrant. All right. So similar thing with this one, we have 0 is equal to cosine 2 theta plus 3 sine of theta plus 4 sine squared of theta. This one's a little bit more in depth. So once again, we want to use the single angles. So this cosine of 2 theta is a little bit of an issue. So if you look at the other two terms, they're just sines of thetas. This one's a sine squared, but they're singular angles. So from my identities, I know that cosine of 2 theta is equal to cosine squared minus sine squared. I also know that it's equal to 2 cosine squared of theta minus 1. I also know that it's 1 minus 2 sine squared of theta. All three of these are equivalent. Now, I'm going to replace, since these guys have a sine in them, it doesn't make sense to use one with cosine in it because I'm just going to introduce different trig function. So I'm going to use this 1 minus 2 sine squared of theta and replace cosine of 2 theta with it, just so that I have only sines to deal with. All right, so it looks a little awful, but we're going to clean this up. And I'm going to combine these two terms, these sine squared terms, and I'm going to get 2 sine squared theta plus 3 sine theta plus 1. All right. It's a quadratic. Don't worry. We're going to factor it. Oops, 2x squared plus 3x plus 1. I told you our little trick. Make it look like a x quadratic, the ones that we're a little bit more comfortable with. And everything's positive, and the only term here is, the only factor here is 1. So everything's going to work out really nice when I factor this. How this factors is how this factors. Same, same. So 2 sine theta plus 1 and sine of theta plus 1. Same pattern, just with sines instead of x's. All right, so we're going to get too many trig problems. Okay, we get 2 sine theta plus 1 is equal to 0. Means sine of theta is negative 1/2. Okay, and we have these answers from before. It's 210 and 330. Okay, and then sine of theta plus 1 is equal to 0. Sine of theta is equal to negative 1. If you think about the graph, which is the way I like to think about it, that occurs at only 270.